Hi friends, in the previous video we have discussed the algorithm and have built a regular expression for a given finite state machine. In this video we will take up one more finite state machine and obtain or build the regular expression for it. This is the given finite state machine where start state is A and accepting state is C. As per the algorithm, the first step is to eliminate all unreachable states from the start state. Here start state is A. First we are supposed to check whether all states are reachable. From A, state E is reachable, state B is reachable, A to B, B to C, C is reachable, A to E and E to D, D is reachable. Since all the states B, C, D and E are reachable from the start state A, none of the states are being removed. Second step is, if the finite state machine doesn't have any accepting states, then it must halt and return the regular expression as null. Whereas in this finite state machine, it has an accepting state which is C. In the third step, if the finite state machine start state is part of a loop, then we are supposed to create a new start state S. Here start state A is part of a loop, 0, 3, again 0, back to A. So since it is part of a loop, we are supposed to create a new start state S with epsilon transition to the old start state A. In the fourth step, if there are more than one accepting states in the finite state machine, or a single finite state having outgoing transitions, then we are supposed to create a new accepting state. Here in this finite state machine, there is only one accepting state C, from which we have outgoing transitions 0 to D, 1 going to B. Hence, we are supposed to create a new accepting state F with the epsilon transition from the previous accepting state C, and now you can see here C is no longer an accepting state. In step 5, at this point, if the finite state machine has a single state, that is the start state is the accepting state and no transitions onto it, then the finite state machine halts, returning a regular expression as epsilon. Whereas in this finite state machine, there are more than one final state. Next step, that is in the sixth step, we are supposed to go on removing all the states one by one until we are left over with the initial state or the start state S and the final state or accepting state F. So let us start removing or ripping the states A, B, C, D and E one by one. Let us start with removing state D. If you observe, state D has incoming transitions from E, B, C and a self loop, whereas it doesn't have any outgoing transitions to any other state. It means state D is trap state. On eliminating trap state and all its transitions, the transition diagram obtained is this one. Let's remove state E. State E has an incoming transition from A and outgoing transition back to A. It means it creates a self loop to state A. On eliminating state E and all its transitions, we get a self loop to A with the regular expression 0, 0. Let's eliminate state C. State C has one incoming transition from B and two outgoing transitions, one to B and another to F. On eliminating state C, we get four possibilities. One, do we have any transition from B to F through C? So we can see here B to F through C we have 1 epsilon. So we have from B to F a transition with 1. Second, from F to B, do we have any transition through C? No, we don't have any transition. Next, self loop to B through C. So we can see here B to C for input 1 and again from C to B for input 1. So there is a self loop from B through C back to B with string 1, 1. So we have a self loop to B with regular expression 1, 1. And fourth one is we are supposed to check, is there any self loop for F through C? So that is not possible here. So on eliminating C, so this is the transition diagram obtained. We are left over with A and B, two intermediate states. Let's eliminate state A. State A has a self loop with a regular expression 0, 0, a incoming transition from S and an outgoing transition to B. On eliminating A, we have a direct transition from S to B with the regular expression as epsilon 0, 0, it is a self loop, so 0, 0 whole star followed by a 1 reaches state B. So on eliminating state A, the finite state machine obtained is this one. Here still we have one more intermediate state B which is to be removed. Last is to remove state B. State B has an incoming transition from S, a self loop and an outgoing transition to F. On eliminating B state and all its transition, we get a direct transition from S to F with a regular expression as 0, 0 whole star 1, again a self loop 1, 1 whole star followed by a 1 reaching the final state. So here is a stage wherein the finite state machine is left over with only one initial state and a final state. Then the regular expression built from the finite state machine by state elimination method is 0, 0 whole star 1, 1, 1 whole star 1. Thank you.